Chapter 25, Problem number 22. A small statue has a height of 3.5 centimeters and is placed in front of a concave mirror. The image of the statue is inverted, 1.5 centimeters, and located 13 centimeters in front of the mirror. Find the focal length of the mirror. So I'm going to first start off by plugging in the values where they are relevant. So the height of the image is 1.5 centimeters. The height of the object is 3.5 centimeters. And the distance of the image is 13 centimeters. We don't know the distance of the object, and we ultimately want to find the length of the focal length. So I am going to use these two equations right here. The height of the image divided by the height of the object is equivalent to the distance of the image divided by the distance of the object. And I'm also going to use this equation right here. This is the first equation. The next equation I'm going to use is 1 divided by the distance of the object plus 1 divided by the distance of the image is equal to 1 divided by the length of the focal length. I am also going to convert all of the values that was given to us in the problem. So 1.5 centimeters is equivalent to 0.015 meters. 3.5 centimeters is equivalent to 0.035 meters. And 13 centimeters is equivalent to 0.13 meters. I am going to use this equation first because we have the height of the image and we have the height of the object and we also have the distance of the image, but we do not have the distance of the object. Once we find the distance of the object, we can plug it into this equation right here, and because we have the distance of the object and the distance of the image, I can easily find the length of the focal length, which is what we ultimately want to find. So I'm going to rewrite this equation right here. And because we want to look for the distance of the object, I am going to do a little algebraic manipulation, and I'm going to multiply both sides by the distance of the object, and then I'm going to divide each side by this value right here, the height of the image divided by the height of the object, and once I divide both sides by this right here, it's basically the same thing as saying multiplying it by the reciprocal. Therefore, I'm going to get a final equation of this right here. I multiplied each side by the distance of the object, and I divided by the height of the image divided by the height of the object, or I multiplied each side by the height of the object divided by the height of the image. And once I do that, I'm just going to plug in values. Distance of the object is equal to the height of the object, which is 0.035 centimeters divided by the height of the image, or 0.015 meters, and then I'm going to multiply by the distance of the image, which is 0.13 meters as well. For the distance of the object, you should get a value of 0.3033 meters. After I find that value, I am going to move on to the second equation right here, and I'm going to just plug in the values. So 1 divided by 0.3033 meters plus 1 divided by the distance of the image, which is 1 divided by 0.13 meters, which is equal to 1 divided by the focal length. I came up with a value of 10.99 meters is equal to 1 divided by f. But this is not the focal length. What you have to do is raise everything to the negative 1 in order to find the focal length, because right now this is 1 divided by the focal length. And so once I did that, I found that the focal length was equal to 0.091 meters, or 9.1 centimeters. And this was the final answer for the focal length. And just to recap, in order to solve this problem, we needed two equations. This one right here, height of the image divided by the height of the object is equal to the distance of the image divided by the distance of the object. And we also needed this equation right here. 1 divided by the distance of the object plus 1 divided by the distance of the image is equal to 1 divided by the length of the focal length. Once I found the distance of the object from this equation, I plugged it into this equation, and because we already had the distance of the image, we could easily find the length of the focal length. And that was found to be 9.1 centimeters.